So let's start with bagging. Here is our data in the form of some red and blue points. And for simplicity, we will say that our weak learners will be the simplest possible learner, a decision tree of one node. So all of them are either horizontal or a vertical line that says on this side everything is positive and on this side everything is negative. So back to our data. Let's do the following. Since our data may be huge, in general, we don't want to train many models on the same data. This would be very expensive. Instead, we'll just take subsets of it and train a weak learner on each one of these subsets. Then we'll figure out how to combine these learners. So here's our first subset of data, and our first model, our first learner, is this one. We'll remember this one. Now here's our second subset of data and our second learner. And if it looks like I'm being too lucky picking my data and my learners, yes I am. In general, these learners can be terrible, but if our data is large enough, picking a random subset normally gives us good intuition on the data. Plus, it makes the process run quickly. And finally, our third subset of data and our third learner. Notice that I never partition the data. We are completely allowed to repeat points among our subsets and to even not consider some of the points at all. At every step, we pick a fully random subset of data. And now we have three weak learners. How do we combine them? Well, what about voting? We overimpose them over the data and say, if two or more of them say blue, then blue. And if two or more of them say red, then red. If we had an even number of models, we can pick any way we want to break ties. Although with lots of points and lots of models, it's hard to imagine that we'd get a tie somewhere. It may happen though. And voila! This is what we obtain when we make the models vote. So that's it. That's the bagging algorithm.